Oh, looks good. All right. Hey again. So, turning a new page. We're going to be working on MPEG transport stream, which, as you can see, is an old thing that is literally shot out of these big TV towers that you can see around the place. And if you've got digital TV, or if you use digital TV, which you have to in Australia, I think they turned off analog TV some years ago now. But the vision and the audio is transported using MPEG transport stream, which is a media container, just like MPEG-4 or WebM or MKV, which we see. Yeah, this is one that's specifically designed for streaming rather than like that kind of like, rather than like say a DVD, which has, you can seek arbitrarily and do a whole bunch of stuff, extra stuff. So I'm hoping this one doesn't take too long because I've actually already done this before, but that one is not open source. But I remember most of what I've done, and I think as I work through the spec, I think I'll remember stuff. Why are we doing MPEG transport stream? Basically just because in our self-hosted stream, which is, I don't know, somewhere. Hosted, here we go. In our self-hosted stream, which is, we're actually, I don't know, somewhere. The browser or whatever player you've got will actually be downloading these MPEG-TS files. Hosted. Now, just as a quick intro, we can actually get this. And I'll just do a quick, now, Wireshark actually knows what MPEG-TS looks like. So let's open it up and just have a look. I think that's the one that we just did. 1K, yeah. Okay, awesome. Okay, this is a good one. So, MPEG transport stream. We have that open, and then let's open also, all right, Wikipedia. Okay, very similar to what we were doing with Scuddy 35. This is a binary, whole bunch of binary encoded sort of information. The most important thing to know is that all of these things, it's transmitted using 188 byte packets. That's the first thing that we need. We've got some important stuff at the beginning, and then we've got some other like subfields. So we've got a header, and then we can have other kinds of information in there. So split up, it's kind of, you've got like your header, and you've got a few other fields. I think 2 or 3 possible others. And then of course, down the line, you've actually got your payload, which actually has, the video or audio, which could be H.264 and AAC, which is what that's what you'd be watching right now. If you're watching on Twitch or from our own live stream. Pretty cool. So rather than kind of go through it like this, I think the more of the value will be seeing me just kind of like bash my head against this thing and just kind of like just kind of hacking away at it, because if I wanted to do like a more educational sort of introduction thing to the actual format, then I'd probably like plan something. I'm not planning anything here. Let's just go for it. So I've started a new package called MPEG-TS, and this is what we're going to do. Package MPEG-TS, import something, I don't know what yet. Now, the first thing I want to do is the packet size. 188, we know that. Next up, we're going to need a packet. And here's what we're going to have. Now, the sync byte, I know. Let me just see if this is clear. Yep. Just write this down here. Okay. Now, this sync byte, I don't think we need to store, because rather we don't need to export that. So let's just do sync, and this is a, yeah, it's just a byte. Let's put that down. Let's store it here in network order. An actual layout in the packet. Okay, the error indicator. Yep. Okay, so this is something that when, say for whatever reason, you know that there's something wrong with this particular packet, you can just mark it as such, and then the decoder on the other end should just discard the thing. Okay, payload unit start indicator. Tee-hee-hee, funny name. The first byte of a new payload unit. Packet data. Can't remember about that one. Let's do this priority. So that's another Boolean. Let me make this smaller here. Yeah, good morning, Mr. Yan. Yeah, just about, almost. Good afternoon, technically also. It's 25 minutes past noon here in Sydney. PID is 13 bits, okay? So our old favorite, you know, saving, if you can save 3 bits, then why not, right? And this thing just tells you what is actually, you know, like almost like the type of the packet. Well, not really, like maybe well, as it says, tells you what is actually in the payload. I think we all remember the important stuff. Yeah. I just can't remember what it... turns the first byte of a new payload unit start. So I almost just want to... I'm going to call that payload start. Because if this is true, that means that the payload, it is the start of the payload. So from there, you know, any decoder can start going, okay, well, this is the first byte of the video or the audio or for whatever. And I'll start pulling it out. Remember that because this is used for streaming, this stuff is, we're going to run into a lot of things that are like if you pick up any packet any of the way through any particular byte, Yeah, so there's a lot of things that kind of count for the fact that we could just be reading any byte at any time. You just jump into the thing just like your TV does. You turn it on, it doesn't tune instantly. Right? It usually takes like a little bit of time. That's because it's working out all of this stuff. I should actually have like a real TV behind me or something like that. That would actually be quite... I should almost like get a fucking like antenna and stuff and just like broadcast TV to it. That would actually be kind of fun. Like sort of analog style, but not. Okay, so packet ID we've done. Let's go down to Coding Garden Fan. Hey, Coding Garden Fan. Concha. Sorry, I can't see the pictures in this thing. I assume Conch is going to be... No, Conch. I'm thinking Conch the shell, but I don't know. Okay, transport scrambling control is... Yeah, right. Okay, so let's golang go. Let's call this scrambling, and the scramble control maybe, and then we're going to have a type called scrambling here because there's some special values that we need to do. So let's go scrambling. We'll just scramble. And this is going to be, we've got 4 possible values. So the smallest we can jam that into is a, well, yeah, let's just do a U and 8. And then let's do our constant. So let's go scramble none. That's 0. Oh, is it scramble? The next one is going to be scramble. Okay, reserve. So let's do that, and then we're not really going to be able to use iota, can we? 0. I'm going to start with 0, and then we can we shift this? Just do this for now. That's reserved, so we'll keep that there, and then let's go scramble. Adaptation only. Oh, sorry. Even key. Oh, so scramble even, scramble odd. Easy. Oh, reserved. Sorry, my bad. So that's OX80, and this is OXCO. Okay, so this is really only relevant for actual TV. So this is when, you know, if you've got a TV tower and you're broadcasting stuff and you want the, you know, stuff in your packet to be encrypted. or scrambled. So they didn't even use the word encrypted, right? It's scrambled. Funny. Okay, let's do that. Let's keep going down. Adaptation field control. So this is something that tells us if the adaptation field is there. And we're not going to need that, at least I don't think so. Payload only. Yeah, okay, so for us, we're not going to need this because we're going to have adaptation field and payload. So here, we're going to go adaptation is going to be some struct that I can't think of right now, and then our payload is really just going to be a slice of bytes because we don't know or care what is in there. Let's start the formatter. And then like that. Cool. Now that has to be a adaptation field. Tempted just to call that adaptation. So this is going to be actually a pointer to it. So instead of having a struct field for our, we'll just handle this when we're encoding and decoding it. So this is only for the wire format, really, that we care about this thing. Okay, so adaptation, payload. Cool. Okay, let's put a adaptation here. And right now we're just going to do an empty struct because that's fine. And should we document it right from the get-go? Let's do that. The sync byte, I don't think we care about either because, again, it's only for the wire that we care about, that sort of thing. I wonder whether this needs to be a... If true, the packet should be discarded, okay? Priority is if we... Yeah, okay. Higher priority than other packets with the same PID. Pretty easy. Payload start indicates that whether the payload contains the holds. Yeah, for Parsing shall start this to know when it can start. Yeah, okay. Okay, yeah. Okay, so holds. Yeah, that's good because start and first byte, that's good. So we don't want to just use the same words. We want to try and explain a little bit more here. Whether the payload holds the first byte of a because it's not just audiovisual data here. There's also going to be other like kind of stream metadata that could be in the payload. So I'm just trying to think. of a, maybe just of a particular type of particular data type. Ugh, I don't know. Let's do an example. So such as, you know, so this would actually be a fun way to, I mean, if you were really kind of like, you know, like crazy or weird or whatever, you can actually, you know, you can use MPEG transport streams to just transport anything you like. I mean, you could just send over like text and stuff if you wanted to. You could use it to like transport, like, I don't know, like, you know, like control sequences to a video game or something. And as long as the thing actually, the receiver actually is able to manage reordering the packets and stuff like that, or if you're using TCP or something like TCP, then you can just transport whatever the hell you like. It's kind of a really bad idea, but it's also kind of a really fun idea, I think. Yeah, I don't know what that is. Okay, packet ID. Yeah, this is really just for... This is... Oh, .des. Okay, damn, yeah. All right, so let's say this is for... specifies... These are two different algorithms. Is that a different? Yeah, which algorithm? Is it just the payload or? Yeah. Which algorithm, if any? Okay, and then the adaptation field is, let's just leave that for now, and the payload, okay, whatever. All right. Quite sure how to do this. And encoding and decoding of MPEG-TS packets as specified in is it an ITU spec H dot? So we know H.264. Well, this is H.220. ITU. Look at this modern website. Damn. Okay, pretty good. Cool. Let's go. MPEG-TS. You know, this is a new, yeah. Nice. Okay, I'm just going to look at the okay. Yeah, it looks good. Okay, now we can start now with a, let's just start using the, what's this, MPEG-TS, decode. So we're gonna decode from an IO.reader, and then we wanna return a single packet and error. Hey, so we know our buffer is always going to be 188, so which is packet size. Now we can start dealing with the sync bytes and stuff like that. Okay, actually let's have that, yeah, let's have that here. Okay, great. Okay, first byte. Our first byte of our new package. Ah, that's so sweet. Oh yeah, do this and equals r.read buff if. Now, what do they always say about this? This is the thing about, it's a len, but it returns a number of bytes read at any error. If read returns n less than p, it may use all of p as scratch during the call. Some data is available, but not limited. Yeah, this one should always process ngo before considering the error. Yep, okay, so. you really want to get that, maybe we can just do that and then and then if we've got a non-nil error, then we can sort of add it as context, and if not, then, well, shit happens. Right? And okay. There we go. Good. Now we can get our first byte. Now this is pretty easy if we don't have our sync byte. It's just sync, isn't it? Yeah, should be it. What do we do for that? Oh. Actually, let's do that. Yep. Okay. Okay, now we can actually do our packet and then need, yeah, and then we can, now we can start filling in our packet. So next one is our error. So let's go if buff, so we're going to grab the first bit. It's going to be OX. So we're just seeing if that bit is toggled, I think. I've already forgotten my binary stuff already. It didn't take long, eh? Okay. Oh, this is a hex table. I cannot fucking remember this. Yeah, OX80, yeah, exactly, yeah, okay. We got that, easy, okay. This should be a little bit easier than when we did the Scotty35. I think I've learned something, right? Payload start, do we care about that one? Yeah, we do. Oh wait, where's the priority? Oops. Let's order these the right way around. That. Yeah. Apparently that's OX40. Man, I suck at computers. Yeah, OX40. Okay, OX40. Then the payload start is true. Whoa, 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 whoa. X20, next Yep, next bit along. Okay, now we're going to read a packet ID. So this is split between 2 bytes. Okay, so we've got, let's actually just do a packet ID. I think there's some, yeah, let's just make one up. So we're going to go, I'll just print one here. Let's do 4, 7, 8, whatever. And let's print out the binary of that. 16B. Print out all 16 bits. Hey, Kai314. I need to do this, don't I? Now, actually, this isn't really what I want because the layout is going to be split between, again, so we've got 13 bits. So we want the second, yeah, we want 13, on the next 13 bits. So that's 5 from buff 1 and all of buff 2. Why we want that is we've got because we've already dealt with 1, 2, 3 bits, so those are taken, and then we've got some bits left over. So let's call this what's a nice thing? 1, 2, 5, 1, 2, 3, 4, 5, 6, 7, 8. Right, so these ones are taken up already, and we've got 5 bits and then 8 bits for our 13-byte packet ID. So how are we going to do this? We want to let's read a uint 16, big endian, uint 16. So we're going to read it from this byte and this byte. But we can't quite do that because we need to mask off these 3 bits. So that mask is going to be 111, like 000. I've missed a bit, haven't I? 1, 2, 3, 4, 5. No, that's good. So let's 111. So it's 000 1. So it's 1 for F, right? Yeah. And then this is just going to be FF. So that's our bit mask. And I assume that's going to, yeah. Yeah, OX. Oh, yeah, okay, cool. Now this actually makes sense now. This is so much easier than when I did this a year ago. You got no idea. Okay. Let me just confirm what that looks like. Coding binary. Byte order. Yep. Okay, so we're going to make a uint16. Okay, so we need 2 bytes. So let's just do a new with OX1F and then just all of buff2. So that should be like that. And then that just gives us a uint16. So now we can just say p.pid equals that. All right. Okay, let's, oops, this one, scrambling. Okay, so it's 2 bits. So where are we up to? Okay, so we're up to a new byte now. So let's reslice. I often like to do this just because then we know that we're done with all those other bytes, especially because we've sort of got 2, 4, 8. Oh, nice. Okay, that actually fits in quite well. So this is a fixed size. 4, 8, 16, 24. 24 bits, 8, 16, 24, 3 bytes. Quite a lot of information in 3 bytes, eh? So the p.scramble control. I don't know, scramble control. I just don't know what that is. Is scrambling? Is a scramble? Yeah, I don't know. I mean, doesn't really matter. It's the next byte, but only the next 2 bits. So that's going to be apparently that. OXC. Oh, yeah, indeed it is. Really split this out. There's a bit of logic in one go. So buff3, yep, okay. For our adaptation field control. Ah, okay. Okay, so the field control we can leave that. We don't really care. Although, I mean, we'll keep it in memory, but we're not going to store it in our struct because the value of those 2 bits will tell us whether we need to like grab these things or not. Okay, so let's we can just store these as kind of two booleans. So one will tell us whether there's payload only or yeah. That's, so we could even do an if here, or actually let's and or payload okay, and then so the continuity, which we never even stored here, so let's see that continuity is a sequence number of payload packets within each stream incremented per ID. Okay, so this is just going to be a uint8 as well. Because this is just like an actual number that's used like a counter, and can't do 4 bits, so we'll just store it in a uint8, a single byte, and then so p.continuity equals the last 4 bits of the last byte. Last 4 bits are, oh yeah, OXOF, yeah. Okay, there we go. Okay, that's pretty good. It should be that. Let's just have a read of this thing now. Okay, that looks pretty good. So, what can we do? What can we do? Let me save that for now, and then I'll just close that. Just put that in one. Variable length, yep. There's our adaptation field. And is all of that, yep, okay, and then something else, and the payload. Okay. Packet, what was that, PID? Now we should probably store these values. So we'll have these as constants. So our PID won't just be a uint16, it'll actually be a, like a packet ID, which, yeah, contains all of this stuff. Again, this is stuff that's tables null packet used for fixed bandwidth padding. Yeah, okay. All right, that's cool. Okay, let me just do a quick tea break and stuff. I'm gonna get my, it's just started raining, fucking hell. Oh, card 314, sorry, I didn't see your messages. So we're working on MPEG transport stream. So we're doing a little MPEG transport stream package. I know we were going to do RTP and or SRT, but in the end, I figured I can probably do an MPEG transport stream, and then since we're actually using it for the self-hosted stream. And then, and then from there, move on to RTP. And I think that then from RTP, we can actually put MPEG transport stream into RTP. That's what I'm thinking we'll do. So it should be pretty, that's my thinking on what to do next. Because then we're kind of building up the thing, like our packages will kind of work together then, rather than just kind of randomly hacking on like specs and protocols and stuff. How is the weather in Australia? Well, I mean, right now it's, so here's Australia. There's Indonesia, nice and warm. That's the equator there. And we're down here in Sydney. I love the weather. I want to learn more about the weather, but I'm too busy with tech stuff. What we're getting right now is a cold southerly coming in, which is, it's pretty cold, right? 15 degrees. This is Celsius, by the way, for any Americans. So yeah, it feels kind of cold. It's rainy. We go to, is this going to work? Oh, cool. Okay. There's the cloud. So Sydney is a little bit unusual because it's kind of got like a wet and a dry season, even though it's not really tropical. So, but I mean, it's subtropical, right? So it's not like Europe or something where it's crazy. But our winters are dry and our summers are wet. So the driest month in Australia is August. And right now it's the 6th of June. So we'll get a little bit more rain for like 1 or 2 more months. And then it just gets like super dry. So, yeah. That's what's happening. And as you go further north, it gets nice and warm, right? See, 20, 21. So I've got family up here. And then Cairns, oh, I love this place, beautiful. Some of the oldest rainforest in the world is up there. Really special place. 15. Oh, in the Caribbean. Oh, yeah. No sun today. Yeah, no. 15. Yeah, well, as I said, it's like, it's sort of a bit, it's a little bit tropical here. So 15, yeah. It'll get down to about 10 degrees. That's as cold as it gets. Oh, Florida. Yeah, well, geez. Yeah, let's see. Hold up. In the Caribbean, yeah. That's 28. Nice. So the equator goes through Ecuador, right? So there's Ecuador. I wonder how far that is from the equator. See which is closer to the equator. It should be pretty, if you're all the way down there, yeah. I know, Sydney is about San Diego or LA. It's about the same level. Yeah. Of course, that's super dry, but, Yeah, nice. That would be nice to go down there. -40, fucking hell. 22, yeah, nice. -40, shit. I've never felt colder than minus. Well, look, I used to live in the Netherlands, so I'm a pussy, absolutely. But I know, I get a little bit of a little bit of what cold is. So I'm not going to pretend that I'm not a pussy. Oh, dude, what the hell? It's only 10 degrees now. Ugh, fuck that place. It's so cold there. Obviously, it's nighttime, but still, fuck. It's like it's June. It's shit. I don't know how I lived there, to be honest. Yeah. Basically same weather as Sydney, and it's June. Crazy. I'm here. I've got 2 jumpers on, a shirt, and a t-shirt underneath. Is that weird? Well, I've got family. Yeah, nice. Oh, the snow. Yeah, I've only had snow in the city like a couple of times my whole life when I was living in the Netherlands. Like for me, it was amazing. Never seen that before. Netherlands, is that weird? I'm part Dutch Indonesian. So my grandfather is from up here in the north, and my grandmother is actually from Indonesia. So she's from Java. Okay, I'm gonna get tea and stuff, and whoops, and then we'll continue on the MPEG transport stream journey. Any burps or farts? I don't know. What do you think, Kai314? Have there been any? You got that strong Dutch look. Yeah, I don't know. Okay, I'll be very quick. Let me just do this. Oh, let's just sort of. Oh, let's zoom in. right. Yeah, T-Rex sounds good, isn't it? Yeah. Easier than doing on OBS, right? I'm drinking peppermint tea. Dash. Oops, dash. Oh, Twitch TV. Yeah, it's good, isn't it? It's yum. Okay. I just wanted to check that. Yeah, cool. Okay, great. Close that. Now, straight away, I think we can actually just write a little program. What I want this program to do is, let's do a little Excali. Very simple program. So this one here, and that one, MPEG, and that's going to read to there, and that's going to be, our MPEG, the TS dump. Let's call it that, or TS. I don't know, whatever. TS read, yeah, something. This is just going to be a pipe, so. And then let's get our source, which is just going to be some, bbb.ts or something like that. So we're just going to get a transport, an actual file. And no, sorry, no, you know what? Let's get a, forget all this. Forget all that. What we're going to do is we're going to write a little program, a very Unixy style program. So TS read. It's going to run a little something like this. We're going to have a command that just, TS read, and then we're going to give it a file. Or we could do something like, cat out.ts and give it to TS read. And then it's just going to print out some stuff to standard output, like diagnostic information. Let's do some usage. That. file for now. Let's just read from standard input. Okay, so very simple. Let's just go packet is going to be our MPEG-TS dot decode from standard in. Let's print out something like, really want to print out that PID. Okay. Now we're only going to read one packet. So actually, let's read a few packets. Yeah. Do a oh no, because we can just, yeah, we'll just do that, and we'll keep advancing the thing by yeah. Howdy, maniac underscore 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 underscore. How's it going? Howdy, partner. Is that going to go? Yeah, it should be fine, and then we'll get EOF, and then we'll, yeah, and then we'll exit, right? Cool. Yeah, good, thanks. I'm excited doing a new package, so gonna just slowly, you know, get more of this little stream kind of hosting itself. And I actually wrote this MPEG transport stream package before, about a year or maybe even 2 years ago now. I can't remember. But it'll be nice to, you know, publish one open source. Oh yeah, nice. Sounds good to me. Sounds good. I'm getting cozy now. I've got the heating on. Hopefully that's not too noisy on the microphone. I don't know. Actually, yeah. Is that noise okay? I don't know if you can hear that or not. I could turn it down a bit. Okay. I'm just going to turn it down a little bit because I don't have a monitor, so I can't. Yeah, okay, cool. Okay, I've just turned it down a bit, so hopefully that's okay. Anyway. Cool. Nice. Okay, cool. Thanks. Yeah. Okay, so we're just going to keep reading in from standard input. So let's run this thing. TS dot, and then let's read it from. Oh, whoops. Okay. I've been coding in Go for about probably since I think 2019. But I was just doing on and off like projects and just very small tooling since like 2016, I think it was. So yeah, something like that. Maybe even 2015. Yeah, writing, at that time, just writing like tiny little monitoring tooling, stuff like that. Yeah, I did, yeah. So, at least relevant to this stuff is I was using Go to write, like, sort of like system-y software for the TV stations here in Australia. How about you? Are you, yeah, not super low level, but low level in the sense that, like latency was important. You're dealing with bytes. Not doing like assembly or anything like that, but yeah, maybe more like that sort of network systems programming, I guess. Oh, what am I doing? What am I doing? I'm losing it. Okay, there's that. Let's be running that, yeah. And then where's my, this thing. Oh, finally return. No. Here we go. Cool. There are packets. So just to get an idea, yeah, great. Okay, this is good. This is good. Let's be really clear on what we're working with here. Oops. So this is the file that we're dealing with. This is just some recording. I just grabbed this from the live stream that's streaming right now. I know, somewhere. Okay, so it's about 4 seconds of stuff. And in those 4 seconds, there were this many packets. Many packets. And we know exactly how many packets. That's pretty easy because we can just get the, so it's at a megabyte. 1026, yeah, okay. And then we get that divided by 188. That's the number of packets are in a, okay, there we go, 5,460 packets. Let's open it up in Wireshark and see we're getting the right thing. So if we open up this, find the header and the packet ID. Let's go to the very first one. 256 apparently. There's our counter going up at least. Oh, so it goes 15 and then 0, 1, 2, 3, 15 and then back again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 15 and then 14. Okay, yeah. And then we start getting some other stuff. Yeah. Let's filter for... I want to find where the packet ID is not 0x0100. But that is indeed 256, right? For binary people, yeah? Because, yeah, 1 byte 255, yeah, and then 1, 256, yeah. Great, okay, so that looks good to me. Let's, I'm new to this world, this guy, just learning data engineer. Oh, yeah, nice, okay. Yep. Yeah, cool. Yeah. That's cool. I feel like I would have done that eventually. I studied medical science at university, so that's what my bachelor's, what do you call that? Bachelor's degree is in medical science. And yeah, I was super interested in statistics and stuff. So yeah, that's yeah, I would like to do that too, but it's just, there's just so much to learn. You know what I mean? Just, man, never ends. Hey, Swill6. Thanks for saying hello. Very kind. Hello to you too. Nice. Okay, this is good. Yeah, and do, exactly. Yeah, it's one thing to learn and then you got to do it as well, right? Yeah. and then you're doing stuff and you're like, oh shit, like, is it time to learn? And then you think, oh, am I learning too much? You know, you feel that too and you're not putting it, you know, it's just this. Yeah. What I want to do is get some values to this packet ID. Oh, all that stuff's reserved. Let's have a look at packet identifiers in use. Yeah. Yeah, absolutely. To really put this, why am I looking so squished up? Hold on, let me just rearrange this stuff. There we go, that's better. I've got a bit more room here. What I want to do is get a little bit more meaning out of the packet ID. So if we go here, we've got this PID. Almost thinking about calling that packet ID, to be honest. But it's not, it's payload ID, so. What do they call it in the spec? Packet identifier. It's not really the type of the payload really more than anything. Oh no, it is the packet identifier. Yeah, yeah. This isn't, it doesn't identify the type of the payload. It identifies, yeah. So this is for when you're receiving a whole bunch of stuff and, you know, sometimes it will arrive out of order or something like that. And so the receiver goes, oh, okay, well, I know that this packet belongs to, you know, so you know what a good name for this is? ID or just PID. So that's fine. So identifies, you know, the packet in a, you know, it's kind of like a, this is going to be a bunch of like different sort of, let's say like streams going on at once. That's what this does. Eventually starts over. I guess. Yeah, I suppose because like you'll have some streams that finish or whatever, and so then you like roll over or you reuse one. Unless the continuity one as well will do that, so that'll roll over pretty quickly. Oh yeah. Yeah, so we're working on MPEG transport stream, which is a container for media. The sort of easiest to explain use case is when you've got, yeah, like literally how this says, like just a bunch of video and audio and stuff, and then you package it all up and you can just broadcast this direct. So all of the TVs, like digital TVs, actually uses MPEG transport stream, and digital radio too, if I'm right. So yeah. So it's 188 byte packets, and you just sort of throw as many as you want, and the receiver will kind of reorder them, or, you know, and make sense of the things. So you've got a bunch of like packet data, which is what we're dealing with. Yeah, nice. Hey, good luck to you. Good luck on the upskilling. Thanks for saying hi, mate. That was super nice. Cheers. Yeah. Yeah, and so what we're doing is we are writing a little decoder and encoder for those packets. So right now, if you watch on our sort of self-hosted live stream, which is what are we doing? So if we load this up, this is our self-hosted one. And we're doing this in a browser, but it could be in any sort of player. And then we're actually downloading these transport stream files. And these themselves are just 188 byte, you know, just like a sequence of many 188 byte packets, all just lined up next to each other. This is our self-hosted one. Oh, we're going to get an echo there. But and we're doing this in a browser. Yeah, and so we're doing a little decoder for those. Oh, nice. Nice. That is cool. That is cool. I've actually never... I run OpenBSD, so this stream is on my Mac just because it's easy to do the streaming and whatever, but that's cool. Used OpenBSD's VMD. Or VMM, I guess. That's cool. How do you speak to it? Is it over a Unix socket with like iMessage or? Oh. Yeah, right. But then how do you speak to the, how do you communicate with actual Beehive? Okay. Yep, gotcha. Cool. Very cool. Yeah. Yeah, well, I guess that's where the application comes in, I guess, right? Let's do this as a new type. I'm going to do this up here. Let's do packet ID is a uint16. Let's do all of these. Pat equals as a packet ID and is, now we start counting. Planning to re-encode streams, or what's the long-term goal? Yeah, that's a good question. So not so much to re-encode, because we're not really dealing with like the well, I mean, yeah, in a sense, yeah, certainly to be able to like transmux things. So go from you know, for example, this stream now, the one that we're running right now, this does RTMP to Twitch and YouTube. And then from there, that's, let's just do Twitch just because it's easier. And then that actually goes to the player. Now that's kind of interesting. But there's a whole bunch of stuff that we don't really know how it works. I mean, pretty much the whole thing here we don't know. So here, what we've got running already is actually just something like this. We just do MPEG-TS directly over TCP to a server we've called HLS serve, and then that just does HLS to players. So what we're doing here is OBS is doing MPEG-TS over TCP to a server somewhere, and then you can actually just watch the stream live, and you know, it doesn't take a lot of code at all. Obviously, we can't serve like 50,000 people like Twitch does, or hundreds of thousands of people. But, you know, we can do enough just for a tiny little audience. So I guess the goal is to, one, like kind of peel back the layers and just kind of like explore and see how these streaming systems work. It's also like to not necessarily do web dev in Go all the time, which I think is, you know, like, sure, it's super popular for that, but it doesn't only need to be that. Also, I used to, I've historically done projects like for TV and streaming services and stuff like that. So doing this, I figured, well, I couldn't stand writing resumes and CVs and like telling people that, oh yeah, I know how to do this. It just like sends me crazy, like talking about something rather than just doing it. So I figured, well, shit, like, let's just write some stuff, make it open source, because I've learned so much from people doing that themselves in other, you know, like industries and domains and whatever. So I'm hoping that this also helps other people as much as that sort of thing has helped me historically. Web is boring. Yeah. Oh no, actually it's yeah. It's sort of at the level that we see a lot of the web stuff. Yeah, it's yeah, I don't know. I'm super interested in networking and stuff, but yeah, I think there's so much. There's a big tower of kind of stuff built on web that's very I don't know. It's not. Yeah. I guess that's not all there is. Right, there's so many layers of stuff. Exactly. Shit, man. I don't know. Do I need to ban you just for saying that? You know, I know you've kind of done a little bit of you know, you're trying to censor yourself, but I don't know. Cat TSDT. Yeah, absolutely. Yeah, it's total bullshit, right? I mean, like, it's bizarre to me. I don't know. Like, I think that I actually did a talk about resumes and about this streaming and stuff like that I need to re-record because it wasn't the recording wasn't super actually, yeah, just wasn't recorded very well. So there we go. I think yeah, I don't know. I think certainly with, you know, in like 2008 and 2009, like, you know, with didn't Rust and Go and what else happened? Yeah, there's sort of an opportunity now to, I think, there's just a lot of Java out there that's pretty bad. And so I think that we're getting to the point that is, you know, we're finally starting to see some of that, I think, reach the end of its life. Of course, there's still a shitload of it out there. But yeah, I think there's that. As more and more people use, as there are more and more computers out there, I think like there's an opportunity for people to find a niche, like even more of a niche. So all this broadcast stuff, for example, I mean, I'm you know, doing software development. But in the old days, right, like it was more like electronics. So you'd need some more of like an electrical engineer. But now that everything's gone digital, and not only digital, but it's going over IP, like over the internet, say, then yeah, I think that people are starting to push back in general, because all of a sudden it's like, you know, we can, yeah, I don't know, like we can, yeah, I don't know, there's opportunity to kind of rethink a few things. It's not everywhere, of course. Yeah. This stuff is just going to be... yeah, I mean that, yeah. Yeah, I think, yeah, yeah. I think that'll, yeah. Oh, yeah, I mean, it's hard, yeah, like a lot of this stuff, yeah. Yeah, it is, because it's very, you know, it's you can sort of see it. Yeah. Like this stuff, like, what is this, you know? I think as well, the, you know, somebody said before, right, there's a lot of tooling. What did they just say? Blah, blah, I didn't see the J word. Where was it? Oh yeah, most of it, yeah, just have low entry barriers. Yeah, exactly. So you can sort of get started really quickly. But there's a whole heap of like non-web problems out there. It's really hard to like find them, if that makes sense. Like not necessarily find them, but look, we all know there's a lot of fucking bullshit out there, right? Like, you know, I think the one that always makes me, I'm going to take my glass socks and I'm going to get, okay, it's a little bit of a rant, but stuff that always gets me is that I studied medical science, so I'm super interested in medicine and science and like, you know, the scientific process and health and stuff like that. And not just for humans, but for all sorts of stuff like bacteria and stuff. And one of the things that always makes me laugh is that like with all of this sort of, you know, with all these like generative and just in general, like the machine learning stuff, AI, like, oh, there's these amazing opportunities for AI to revolutionize medicine. And it's like, well, yeah, like I can see absolutely a bunch of like pretty obvious avenues, like, you know, radiography or something like that. But the thing is that it's like, why are people investing all this money into things when, you know, in the medical world, they're still using fucking fax machines? What, like, we're kind of like going way ahead here. Like, we're going to like try and tackle these like really, really difficult problems. Like genuinely difficult. Like biology, you know, whoa, man, that's a complicated system. But it's like, why don't we take, you know, just 1% of the funding that's going to these kind of pie in the sky, you know, machine learning systems and help the medical people get off fax machines. Fax machines. It's like, what the fuck? It's so, it's just going crazy, you know? It's weird. And so obviously there's a lot of like, there's money in there. It's you know, there's money outside of web development. but it's just really hard. I don't know how you get into that kind of thing. I accidentally got into, video world, sort of TV and all that sort of thing, but yeah, it's crazy, just crazy. So the places that are kind of very sort of wide open, like web development, yeah, there's a lot of noise around it, I think, just because it's sort of so kind of crazy. I think for so many sort of weird applications and noise around it, like that you read in sort of mainstream media, yeah, like it is a waste. But I genuinely think there are some really interesting, I can think of a couple of interesting applications. I talked about radiography. Another one that I think would be one application that I've seen that's kind of cool is generating alt text for images on the web. So for example, like, it could maybe like some model could read this or any other image and then make some little alt text for accessibility. I don't think necessarily that warrants like huge sort of, systems and like, huge funding for tooling. Yeah, I think that would be kind of handy. All this other stuff, yeah, of course, it's a shame, I guess. It's a shame. There's a lot of, the kind of the sort of hope and optimism and the funding is going to these things that are obviously doomed to just burn money. When if you could get some hospitals off of fax machines, I think that would be really cool too. But hey, anyway, should we get back to doing this TV stuff? Yeah. Exactly. I think, the text generation is yeah. NVIDIA. You clever bastard. Yeah, let's I just want to try and get some of these packet IDs, IPMP. So is that going to be Absolutely. Yeah, absolutely. And code needs to change and all that. Do program association, am I going to write down the whole thing program association table, or should I just run pat? Yeah. glorifies. Yeah. I think for those things where the where you don't need like precise output, yeah, cops still use facts. There you go. I mean, what? Like, it's just, you know, and the problem isn't facts, right? It's not that facts itself is bad. It's the paper thing. It's the way that information is encoded and transmitted and shared and thought of. It's a lot of like information stuff that is just, you know, using like, sometimes that document sort of model doesn't work so well. Uh, 13 bits, right? So let's just do the hex. Is that what we want to do? Yeah, we'll do the hex representation. Oh, no, let's just turn them. Okay. Now that we've got these names of the constants, let's actually run this, our little scanner again. Oh, packet ID. Cool. Let's do the whole thing. 0, but 0 does have a, we've got a representation with 0, right? Oh, packet ID, yeah. So then this should fail to compile. Yeah. Okay, so let's PID equals, let's do this in 2 lines, a little bit hairy. Cool, okay, there we go. So we're getting a few more. So actually let's run this and then let's get rid of stuff that starts with a number. Oh, is this because my version of grep doesn't even have the V? Do you know much the pattern? What? Oh. And then grep V and then blah, 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 blah. So that. Sweet. Okay, cool. There we go. Now if we go to Wireshark, and just to confirm, so we've got some packet ID unknown. Okay, so let's do a filter and let's say find things where the packet ID is not 256. How do you do this? PID is not equal 256. mp2t dot. Sweet. Okay, no. There we go. Program association table. There we go. So packet 54. Cool. Okay. So that works. We ever do with that Wireshark? Yeah. Thanks, FitWriter. Yeah, I know. I actually found that before. Let me fix that up. It's because the redirect is the HTTP HTTPS thing. No. Why does it do that? So if we go live. Where is it going to? For HTTP, that's so weird. What's the go? Oh, so does that mean that this is also doing the same? Yep. Gotcha. Okay. Sorry. That's listening on... Yeah. Okay. Oh, no, not that one. Sweet. Okay, and then does it give the location? No. Cool. No worries. Good night, Miss Yan. Thanks again for stopping by. Thanks for saying hey. Stay warm up there in Canada. That should be okay now. So if we just do that. Yep, cool. Okay, so that's our very first tiny little bit of MPEG transport stream done. Now what I want to do is actually put that into our little HLS server command. So it's MPEG-TS dot packet size. Such a tiny little useless thing, but doesn't matter. 7 times. Gimme. This go imports is sometimes a bit weird. Right, okay, there we go. Easy enough. Let's now let's try and put in, how are we going to do this? Actually, for now, let's just have this as a slice of bytes. Okay. Because then we can get the payload and just at least have the header kind of done. And I feel like this almost, yeah. Okay, so we'll go, we're going to read these 2 bits because we're not handling that at the moment. Now we can do a little bit of logic and say, well, if we've got the adaptation field, then, you know, put that into that slice. And if we've got the payload, put that into that other slice. And if we've got both, then do it like that. And chop things up. Okay, so we read 2 bits already. Payload only. Okay, so could almost just do a switch. Yeah, and just kind of. No adaptation field, payload only. That is actually probably the easiest, so let's do that. So I have to do a little diagram here. So we're gonna ignore the first 2 bits, and then all the stuff that we care about is just in the next 2 bits. And then 1, 2, 3, 4 for the continuity. So this, do we care about these 2? So what we can do maybe is just do a mask and then or we can just try each bit. Payload only. Or we could just do a bit shift and then just go down. Yeah, because we want to check the two. We want to check the 2 bits, so we could just. So we could shift to the right 4. So then we just have 0, 0, 1, 2, 3, 4, and then the bits that we care about. And then we could just compare. That's pretty easy. So then we can say, well, if we've got 01 or, yeah. So something like that. So if, yeah, okay. Let's do that. So this is going to be the adaptation field controls. As we do AFC. Okay, and we're going to shift it 1, 2, 3, 4 positions. So we get a single byte. So if the value is 1, that is payload only. Adaptation field only, no payload, followed by payload. Oh, so it's really a Boolean thing, right? So 1, 0 means, yeah, okay. So it's just adaptation only, yeah. So it means that field's present, and then we've got both present. This is just, yeah, reserved. I'm not, reserved, yeah. So case OX01, this is the only payload. So that means everything that's left from here to the very end is the payload. So we're going to do from 4 onwards. And then, yeah, that's it. If we've got OX03, that means we've only got the adaptation field. So again, that means that now the adaptation is everything onwards. If both are present, well, then we kind of not really handling that right now. How are we going to do that? We really need to go into the adaptation field and get the length of it. So the adaptation is going to look something like, it's going to start with the length, and then it's going to have all this other things, discontinuity, random access, blah, blah, blah. So all Booleans, which is awesome. That should be easy enough. Maybe we do want to do that. Do we need to keep the length? Anyway, we'll come to that later. Let's just do that, and then if we... All right, we're going to return it with an error. So there's like, cannot marshal both, cannot decode both payload and adaptation. Let's just do that. Let's run a thing and just see how, like, what packets have both payload and adaptation fields set. Just out of curiosity. Why not? Let's see what happens. Oh, wow. What? Okay, so actually none of these packets have, oh, well, we got a spammer. Let me do that. Is it? Oh, it's somebody's timeout. I don't want to ban them just because it looks like somebody's account has just been hacked. So timeout, is that what I do? Ban mod. I know mod means make them a moderator. So yeah, okay. Yeah, nice. And then the message is deleted. Awesome. Great. Okay. Onwards. Interesting. Yeah, okay. Well, none of the... Anyway, that's fine. We need to handle that anyway. Do 1 week. Ah. Can I do that now? There we go. Chat. Sorry, I just... Oh, not a big deal. Oh, okay, whoops. I'll just do time out. Yeah, duration. Okay, there we go. So, oh, fuck. Yeah, okay. Oh, anyway, yeah. Oh, yeah, I know how to do it for next time. Sorry, I've like, as probably people know, like I've only started streaming like 2-3 weeks ago. So, yeah, I'm just so new to all this stuff. Anyway, okay, cool. All right, so that's that bit done. I mean, the next logical thing would be to try parsing the adaptation field. So I'm just reading what we can do is just have our own little, let's do this, adaptation. Yeah, I'm surprised that, like, I mean, I guess Twitch has something like that internally, but it seems like whatever they've got going maybe doesn't work fast enough or something. If they've got anything like that. I mean, I don't know. Okay, the length I don't think we need, because again, that's wire format stuff. So let's go discontinuous. Random access, yeah, okay, random access. Elementary stream priority indicator. Let's just do priority. I think that's it. So not a lot to it there. Of course, we've got these things, but the rest would need to be transport private data. Okay, well. So it would be a PCR program, clock reference sort of 39 bits extension as well as characters base times 300 plus extension. See, this isn't, yeah, okay, so this PCR, so before we were dealing with 90 kilohertz clock, but this is actually a 27 megahertz clock. I'm pretty sure. Because I remember that now. If we just look at another one, if we go to PES, here we go. This is a good little diagram. So this is what we've kind of been doing so far. Sorry, not PES though. We're doing scrambling. Oh wait, no, maybe it is that. Shit, I can't remember. This is what we're doing. This is what we're doing here. So we've done all of this. We're going to look at this adaptation header now. So we've done all these fields, all right? So next up, here we go, the adaptation. Okay, great. Discontinuity, random access, and elementary stream priority. Yep, okay, that's what we've got here, just these three fields. So next up, I just want to read more about that. Yeah, sample of 27 megahertz clock. Yeah, this is it. Jeez, 9-bit? Seriously? Fuck it up. Okay. 33-bit, 6-bit reserved, 9 bits to add on to the end. Exactly, yeah. I suppose the way we want to represent this is maybe our I don't know whether to do a different whether we do a new type. So for example, we could do something like type PCR. This is the, say this is going to be something like the ticks, and this will be stored as a UN64, and then this will be the extension, which is just going to be a whatever 9-bit. So we're going to do UN16, right? Even though it's, hello. So this ticks is the number of ticks of a 27 megahertz clock. So PCR represents a program clock reference. Yeah. Timing information, so it's a reference for timing comparison at the decoder. Yeah, so this is all, okay. So this is stuff that is used for synchronizing things. So what will happen is that you're going to get audio and video. You're going to get packets received out of order. You're going to get yeah, basically stuff like that. You're going to have like how quickly to decode the things. So what this does is this gives a reference for the decoder, like for example on your computer, to actually keep all of that stuff in sync. So it says, okay, well, you know, let's say you get some frames and you get some other frames. Like how do you how do you sync that up with audio? How do you make it so that, you know, how long do you actually you know, need to show that frame for, that sort of thing. Of course, that's set, but the when you're seeking and things like that, you can use the clock. Is that really going to fit in 33 bits? Yeah, as a 33-bit integer. It's 9-bit. And then what we're going to have in our adaptation is a PC, I don't know whether to call this a program clock reference or, anyway, let's just do it like this. PCR is the PCR, a pointer. And so then we'll know whether the thing is filled out or not. So that's 33. Yeah, and then there's 6 reserved bits. So 48 bits. So what we want to do is have OPCR. Okay, set when splice countdown, field is present. Okay. OPCR is also a PCR. And then we've got a splice countdown. That is, oh, what's this? 8 bits? Why 8 bits? Why make it easy? Why? Why make it so easy? I don't get it. Okay, and then we've got a slice of bytes. So private. Just call that. Yeah. And then adaptation extension. Oh, you fucker. Man, this thing. We might be able to... Extension. Let's... And then that'll have a length as well. Yeah. And exactly, yeah. I mean, that's the thing, right? All of this stuff is here because, you know, when you're doing stuff over like radio waves, well, not necessarily, but this is from a time that's not IP. So there's all of this stuff here that is usually taken care of by something like TCP. But because it's designed to, you know, like have a decoder directly on an actual TV or a radio, then you need all of this extra stuff that's usually taken care of by the IP and the transport protocols. Ugh. Seeing how best to get these values. Private data is a slice of bytes, and then we've got... Let's do the same thing that we've done before. So we're going to do extension and stuffing as byte slices as well. It should be okay because we don't... Yeah, that should be fine. Okay. Including the header. And then the payload is still going to be in the packet. Yep. Okay. So payload is there, and then at the very end, you're going to have the continuity anyway. Okay. Payload itself. Let's leave that. Now, probably the first thing we want to do is try and test our. We want to figure out the way to sort of nicely encode and decode this, because I know from experience that this thing can be tricky, right? You've got a bunch of like, you need to round things and yeah. So to test that, we need to be able to test this, which means we're going to have to parse adaptation. That means in here, when we've got adaptation set, we're not going to do the byte size, we're actually going to try and parse it here. So it doesn't just equal the bytes, that's where we're going from. And also this is incorrect actually, look, because this isn't right, because the last byte is continuity, so this is wrong anyway. So it's very bad. So it's everything up to the last byte. So that's going to be, and we know we've got a fixed size here, so that means we can actually, we can kind of fudge it and just say it's 1.8. It's not 1.8, so index 1.8 would be 187, but it's, so the last one will be 187. So we want to read to 186. All right. So it's up to and including. So 187 is, so let's just do it like this. And this is definitely not, right? This is not 3, right? This is at the very end. Oh no, sorry, hold on, fucking hell, wait. Am I losing it? Do I need to take a lunch break? I think I do. Yeah, fuck, okay. I need to take a lunch break. Oh, so payload, yeah. No, this is right. Yeah, this is lunch break. That's a good, yeah. It is, yeah, absolutely, yeah. So 4, yeah. Right, because we're gonna, because we read all of this stuff, and then everything else that's left is either the adaptation fields or the payload or both. Right? Yeah. And we'll do a slice anyway there, because we'll probably, anyway, yep, that's good. Okay, I'm gonna have lunch. So, where's my lunch break sign? Oh yeah, here we go. Oh, actually, let me get the gopher's girlfriend. Hold up, because they come in pairs. Why doesn't he stand up anymore? You lazy bastard. Hold up. we go. audio back on. Let's see how close this thing can zoom in. Woo. Oh yeah. Where's the noise? Tough. Oh, Misty. Oh, damn! I didn't see that they did that. I should have sent. Oh, anyway. I'll message when they come back. Okay, hey everybody. Oh no, I didn't want to check Twitch. I want to check YouTube. Just wanted to maybe just apologize to the people who haven't been speaking to in the chat system there. No, Sigma JavaScript because we got the job done. Oh yeah. Nice. Oh wow, guys, that's so awesome. Hey, listen, congrats to Lohan. Mr. Guedes, fantastic. How do I get the link? Twitch link. It should be, it's linked in the YouTube channel. Hopefully got that. Go another try. Yeah, I think it's all good. Yeah. Good luck, Prime. Hey, Dylan. Hello, Taj. Outside LinkedIn. I don't have LinkedIn. Sorry. You're a legend, bro. Thank you. Sweet. Let's close that. Okay, we're back to it. So continuity is up here. After the scrambling. Yeah. This is what we want. And for some, yeah, okay, and then, right. Oh, you know, the format is working, yeah, great, okay. Now, as that stands, I think that is, let's just do some documentation. as we go, because otherwise, yeah, you know what happens. It's the conditional access table. Wait. Control information table. So, as described in that standard, what are we reading here? 138181, 138111. Generic coding of, oh, this is actually, it's not 11, is it? I didn't even read that right. Okay, don't know what the fuck, don't know what that is. And packet ID. So discontinuous. This is in the adaptation field. So what is this? Okay. So indicates there is a discontinuity between this packet and either the or PCR. So this program clock. Well, actually that's okay. They can just go to the documentation for that. The original. Okay, random access without errors from this point. Corresponds to the start of the sequence header. countdown the number of packets remaining until a splicing point. Oh, hey, this is 2's complement sign may be negative. Is this Linux? No, this is this one here is not OpenBSD. This is running on my Mac. But this particular program was originally developed for Plan 9. I think there's a link in the yeah. This is a really good that contains information about the editor and the yeah, but it's a great little editor. No worries. A lot of people ask, so I've got the information ready to go. Private data, stuffing. Okay, let's let's just see how that reads. Okay, this extension, that needs to be a to-do. Describe, well, I don't know whether I really want to parse all of this stuff because, yeah, just, yeah. And the stuffing is, there's a good way to describe that, but basically it's just to, you know, to always make sure you've got 188 bytes. Here we go. The adaptation field length also reflects the number of stuffing bytes. Early in the length, okay, so it would have to be filling out to 188 because we've got our actual packet, right? And without the adaptation field or the payload, it's 3 bytes. Yeah. 1 and then, wait, 1, 2, 3, sorry, 4 bytes. I think. No, there's 3, sorry. Yeah. So that means that the padding is going to be the stuffing is going to be yeah, there we go. And the private is transport private data. Identifier. It's going to be like kind of for, you know, kind of like application specific, you know. Sort of private, it's not really quite right the word, I don't know, private, it's going to be something like private capacity, yeah, sort of any, yeah, unofficial. Any of these words are better. looks good. There's this one as well. This is a good little diagram as well. And certainly shows the age of it, right? Like, look at this website. Pez. Oh, this is only the Pez header. Maybe others. There we go. Data structures. Pack headers. MPEG. iPhone, no. Nav, no. These Pez. Okay. Yeah, right. Okay, that's fine. So this is, yeah. All right. No worries. Thanks, Sils. Yeah. I agree. It's a great website. Timeless. Yeah. See you next time, mate. Ciao. Okay. Cool. Let's check out docs again. Mm-hmm. Yeah, okay, that seems all right. Let's save this thing. Oh, of packets, yeah. Not much more needed there, and then let's do that. New MPEG-TS package. Okay. All it does is pull in the constant, but anyway. Oh, wait, or not. What the hell? What was that? Oh, yeah, okay, that's fine. All right, let's send it up. Now we can try and really decode the adaptation field. So adaptation, that's what we want, and go back to our, there we go. And actually what might be good to see is a visual of it from this guy here. Oop, or not. Yeah, this one. Yep, so we're going to try and decode this stuff. Immediately following this byte, okay? So I guess we're going to need a, parse adaptation field, and yeah, that's it. And then we're just going to return a adaptation and any errors that we get. Pretty easy. Okay, first is a byte. So this is just going to be, so we'll reslice from this, I think, yeah, just to make sure. So we'll go, the length is actually the int of that. So buff equals from 1 through to the length. All right. Or are we off by 1 there? I'm going to go including 1 all the way to the length. Yeah, that's right. Okay. Now we know we're not going to accidentally like read some other stuff. Okay, now we're just going through these bits. So read the first bit, be OX80, then oh yeah, let's get an adaptation. So add AF, yeah, AF adaptation field. Next bit. Okay, and I'm going to keep going. Is that the next one? Random access, elementary stream priority. Yep, okay. So OX20. Then this is a high priority stream. Okay, those are our Boolean flags done. Next up. Okay, we've got some more Boolean flags, but it's kind of like, now we're just going to check. how did I start learning about this media stuff? I mean, I'm formally studying software with a focus on multimedia, but I haven't got into any of this stuff yet. Yeah, look, I initially somehow I got into it on a work project. Somebody needed help with what was the first project? I can't actually remember now, but yeah, basically this is, there was a project that needed doing, and they only really had like a web developer available. And so I said, oh yeah, well, I know a bit of networking stuff. I've done a little bit of programming. Maybe I can, if you need something like that going, then maybe I can give it a go. So yeah, I just kind of got stuck in, and I needed to adjust a timestamp in some packets in an MPEG transport stream. So yeah, it was a big learning experience, but I was lucky enough that they kind of trusted me to be able to do it in some time frame that was kind of okay for the customer. And yeah, that was that. And then from there, then you need, we need this other thing doing. Okay, well, maybe I can do that. I don't know. We'll see. Yeah. Now I'm just kind of focusing on it. Give me a sec. Let me just grab my phone. Okay, hi. Sorry about that. Oh, hey, JB Pratt. How you going? So essentially, and of course, like people publishing information and sharing information, online is, like where would we? I don't know. Where would I be without it? I don't know. So I'm hoping that this helps other people too. Good morning. Wow. Yes, it's good. Oh, yeah. Whoops. I think our stream just blipped. Okay. Okay. Oh yeah, looks okay. Okay, cool. Cool. Okay, so done that. Now, if the PCR field is present, or if the OPCR field is present. let's just, I think, okay, yeah. So we should be okay to do this in sort of one hit. So what I'm thinking is we're going to go high priority. Okay, so we're going to read the PCR straight away. So if and OX, yeah. Okay. Now we know that we've 48 bits is 8, 16, 24, 32, 44, 6 bytes. So, I'll do I have 6 bytes, and that's going to be from buff. We're going to want another, and so we're going to want another one here. So parse PCR, and this is going to be a 6 byte, and then we want to, I think we can always, yeah, and then we can always return a PCR like that, because we know that there's nowhere to go wrong there. So we're going to get the next be 1, 2, right. I don't know whether that will allow us to do that. I can't remember now with the array, converting slices to arrays and stuff, but let's just do that. And then we'll do and then we'll reslice. So from buff equals now buff from 7 onwards. Oh shit, no, we need to keep that. So buff equals from, how are we going to do that? We're going to 7. Okay, we'll need to store this as the flag. So we'll go flags buff O, right? And then, yeah, all the way down here, we're gonna buff O, buff, yeah, O with flags. Yep. And then we'll reslice, and then they're good to go again. So now, oh no, we'll need to reslice anyway, so flags, so then buff equals 1 onwards. So everything else is kind of data, not just flags. Then we can start reading the flags. And then this is just up to there. And then once we're done, we know that that's where we're up to. So we just throw out the rest because we've dealt with it already. And now this is flags. And this is going to be, so we've done OX10, okay, we'll do OX08 now apparently. Again, exactly the same thing. Because we're just parsing a PCR again out of those bytes. again, reslice. We've done those bytes. Okay, transport private data, set when that's set. Okay, this is going to be more interesting. Okay, so we've read our our clocks. Where's that splice countdown? Ah, there's splicing point. Yeah, whoops, my bad. Okay, wait, did I miss that? Yeah, I did. Oh, what? OPCR equals pars PCR. Oh, that's going to be a pointer. Oh, anyway, we'll fix it up. So, yeah, okay. If flags and OX04, the next flag along, this is going to be the transport private data flag. So we're going to have to read the length here. So the private data is no, sorry, yeah, this is the splice point. Okay, great. Okay, the splice. So that's going to be, that should be pretty easy. It'll be adaptation field splice countdown is it's just that byte, right? Because we've so if none of those, so like if that flag isn't set, or if that flag isn't set, then the next thing will have to be this. And these are all optional fields, so they may not even be set at all. So the flags tell us what's there and in what order. So that means that we're safe to read that one. Sorry, we're safe to just know that that's going to be the next byte. Yep. All right, and then again we're going to do the same thing. Oh no, and then we need to reslice just to get rid of it because we've read it, so it's dead to us now. Again, if we could probably check the length here because that could end in tears. Let's just get going. Okay, the next flag is for the transport private data. Okay, so in our buffer, the length. Okay, so the length of the tlen is buff of buff O. So we've read that, and then everything else is going to be, so the private now is going to be everything from the next byte, which is 1, for this many. So tlen. And then reslice again. From T length onwards. Hey, Black Falcon. Good morning. That should be all right. Yeah, all good. I think. Yeah, we're doing transport, MPEG transport stream now. I figured that would be good just because then we can, well, one, because I've done it before, so it shouldn't take too long. Also because we're using MPEG transport stream in the self-hosted stream. So I thought, okay, well, that kind of fits. Yeah, seems okay so far. I mean, I'm definitely, it's definitely a lot easier doing it now than when I did it first, like a year or so ago. Yeah, seems to be okay. How do we know if the adaptation extension? So we've done checked, so we've done the private, yeah. So now finally we check for the extension. Okay, so that's just going to be the last there, and then see below. Okay, we'll need to, okay, same deal. We'll need to read that byte and then, yeah. Optional fields, okay. Ugh. Length of the header? It's not the length of the header. It's going to be the length of the adaptation extension field. Anyway, that's fine. So we'll so far it seems okay. There's going to be a few tricky things that I see already another package for, which is going to be in our streaming thing. I've got RTP ready to go as well, but I can almost see something like clock, and in there we'll have like a bunch of functions that I think there's going to be a lot of like conversion between 90 kilohertz and 27 megahertz clocks, because we've seen them now in MPEG-TS, SCSI 35, and I guess any application that's dealing with M3U8 will kind of also see it, because, yeah. So I feel like that'll come out too here. So maybe this thing is gonna, but yeah, we'll see. Should be buff 6. Oh yeah, whoops. Nice spotting, yeah. So I think TLAN and then go all the way. Yeah, that should be right. Yeah, okay. Yeah. No, it should be good, because then maybe in our little HLS serve program we could, you know, like just, I don't know, like try and parse the MPEG-TS packets, and yeah, we might be able to, yeah, I don't know, we might be able to cut on a cleaner point or something like that. I don't know. Yeah. Good morning. Lots of people's good mornings. Also, I thought that we'll do this MPEG-TS and then we'll do RTP. And then, because in RTP, there's a spec that lets you, you know, it's like RFC something, which tells you how to transport, well, how to transport MPEG-TS with RTP. So then that kind of gets the things that are related with one another. And RTP looks I mean, as for I think, yeah, was it? Were you saying that you did an RTP proxy? Who was doing that? I can't remember now. But yeah, this one could be fun. Because RTP is used a lot as well. It's used in all these like video calls and like FaceTime audio and yeah, like pretty much any of those things. And having, you know, having like an actual, yeah, I don't know, having a little thing that actually understands what MPEG-TS is in an RTP package might be cool. Yeah. Yeah, exactly. I feel like, yeah. Because then I think we'll understand a little bit more about what was happening before. And I've got a fun way to test, which is actually this camera here. This thing can actually write raw MPEG-TS over UDP, just raw UDP. So a real test of our, you know, of our MPEG-TS library will be, hey, like, can we read the packets coming from this camera? Okay, so the length is there, so that means that the actual raw bytes are going to be everything up to that length. And we reslice. We need to. Yeah, because we could have stuffing. Now, anything else has got to be stuffing. We haven't returned any errors here. We don't really... There's not really any errors to return. Yeah, okay, well, so the rest is going to be equals just the buffer, and then that's it. Return. Oh. I feel like I'm going to do a little bit of... Oh, we're not doing that yet, but... Okay, let's read this. Let's read our clock reference. So the clock reference is a little struct. Looks like that. Where did we have the description of that? PCR, so 9-bits extension, yeah, okay. So 33 bits base, yeah, okay, so this is gonna be the bitch. All right, let's do some 33-bit stuff. So that's the first 5 bytes, right? Yeah, so we want to read, no, we want to read 32. How are we going to do this? We're going to, yeah, I know, it's just so, it's that one thing, it just kind of, yeah. But this, see, we should just reuse the logic that we've done in the SCSI 35. So if we have, yeah, is that 5 bytes, right? Yeah. So we really want this. So in a sense, this is really a presentation timestamp. So this, you see, so this is where the kind of packages start to fit together a bit better. And this is what I don't see in other, how do I say? Like when you look at all the different like Go modules out there, each of them handles this stuff a little bit differently. But in the real world, right? Like, I mean, it's all the same. So I think having that represented in source code helps to kind of, for people to kind of link it together conceptually in their head. Yeah. So this is how yeah, it is like this, really, isn't it? So I'm going to read. I only need 5 bytes, don't I? Oh no. For this one, I need 6 because I've got 33 plus 6 plus 9. It's 48 bits. This should probably be no, I want to keep that as uint64 so that you can do like basic, you know, kind of like easy logic on it. Like if you want to plus, you know, add, subtraction, addition, lets you do that, which is important. Yeah, I mean, maybe we just copy this and then... So the ticks... Let's do this. Okay, so ticks is 33 bits, right? So it's everything... need to get all these bytes and turn them into a uint 64. Gonna need 5 bytes. Ugh. Okay, let's do this. We know we need 8 bytes for a uint 64. Okay. Now let's start putting it in there. So B 0 to 5 is going to be, we want to copy those values in. So we want B to B5, was it 6? Yeah, everything to 6 from A to 5. Well, 5, yeah. Yeah, 0, 1, 2, 3, 4, 5, yeah, like that. And then we want to mask off the final, like the rightmost 7 bits. So it's going to be like this. So we're going to have, could almost have done it. No, anyway. So in a diagram, we're going to have 1, 2, 3, 4, 5, 6, 7, 8. Seven, 8. So all of these are actually we want. Okay. 4, 1, 2, 3, 4, 5. But these are 40 bits. We only want 33, so we're going to need this. So we copy in 0, 1, 2, 3. But now we only want this bit. So that means we need to mask. We need a mask that gives us only that value. So that's OX, and then something that I don't know. 8, yeah, of course, yeah, OX80. Yeah. So, yeah, like that. Let's close that, it's different. And then the rest we don't care about. So we're just going to leave that. So that means that our uint 64 from from B, because now we've put all the bytes that we want into this 8-byte slice, and then we're going to read the uint64 out of it, and then we're good. Yeah. And then, okay. 6 bits reserved. So that's from 33 to 39. Okay, so we've got 1, 2, okay, so those bits are reserved. So let's actually mark this out. That's RR 1, 2, 3, 4, 5, 6. So it's monospace. It's actually when it helps. One too many X's. Yeah. So those things we leave off. Now we're going to get a 9-bit integer. I hate this. I don't know. It's just kind of. It's like a little puzzle. It's not super hard. It's just like you need to just do it just right. And then how many bytes have we got left? We're doing the PCI. Okay. Oh no, yeah, we've got 6 bytes. So 1, 2, 3, 4, 5, and then that is the extension. So that's E 2, 3, 4, 5, 6, 7, 8. This is E. Okay. That's the binary representation there. So if we drew it out like this, it sort of looks like that. So all of that is those are our 33-bit ticks. Yeah. Feels like that. I definitely need the mental gymnastics. Yeah. Okay. These 6 bits are reserved, and this is the extension. So we can let's read a extension. I think we can do this in one line. Let's just do as to x is 16. Okay. So the first byte is going to be I think I'm off by 1 here, but anyway. No, maybe I'm right. No, I think I'm off. How many? Oh God, I'm starting to lose it here. Anyway, okay, let's just do it as we go. And if we're off by 1, we can just shift around. So the first byte is going to be, so that's index 0, 1, 2, 3, 4, 5. So this is B4, but we only want that bit, and that is a bit mask of 0x01. Hacker's delight. That's good. Let me write that down. Where's my notes? Here we go. I'll save that. Thanks. So, Are you still manipulating bits every now and then? That's OX01. And then, oh, this isn't, no, this is A. This is A of our array. And then this is just the last one. So this is 5. So actually just like that. So really we can just return PCR and the ticks and the extension like that. No, I think I need to split this up a bit more. There's too much going on here. I'm not quite getting it. Okay, so conversion of slices to arrays requires 1.20 or later. Yeah, I remember reading about that. Okay, well, there we go. There we go. Well, I know this sounds bad, but I want to keep a little bit of compatibility. I'm not, yeah, so. Like that. And then that should be okay. Oh, yeah, okay. I feel like I just want to do a pointer there. It just doesn't seem right. It's just a value. Don't like that. So I'm going to go down to here. PCR equals parse PCR RP. And then this is PCR. Okay. Looks good. Now this, I'm just not sure about this. So we're going to go 0, 1, 2, 3. Four. Oh, that's right, yeah. No, can't be right. Why am I getting so confused here? Oh no, that is it. Yeah, 4 and then 5 is the last one. No, that's correct. Okay. Whew. That actually looks good to me. Okay. Yeah, that's actually a good little, that's super helpful. So there's the reserve bits. And I could do here is like the, the clock, so C. Let me just do that. Now, the next sort of question is whether or not we return an error or whether we want to try and do a little bit of validation here. So whether we need to return any errors. I'm not sure. A PCR of 0 is totally valid, so that's okay. This is actually not quite correct. This isn't, this is the, yeah, I'll need to change that because this is actually the number of ticks of a 90 kilohertz clock. And then I might, yeah, what we could do is actually times it by 300 in here. So it'd almost really do that. Because then that gives you the actual 27 megahertz clock ticks. And then, right? Because, yeah. The value that's actually transmitted over the wire is a 90 kilohertz clock. But to read the value, it's actually, it's actually that you got to times it by 300, as in turn it from 90 kilohertz to 27 megahertz. Yeah. So, and then the extension is just the number of ticks that you add on to ticks to get the sort of value. So you'd almost have like a PCR and then the kind of the, I don't know what you call it here, like value or sum or maybe, I don't know, yeah, total or Or actually you do base and extension and then a method called ticks that gives you a uint64. Kind of feels like the thing you want. That's how they refer to it, is actually base. So maybe we should do that base, and then we can have a gives you a uint64. Like that. Something like that. We can change that, but because that's not as clear as I want it to be, but because I know that there's a lot of things where you fuck around with these timestamps. So yeah, but for now, let's figure that. So we go. This is a comment here. Kilohertz to. I want to do it here. That. There we go. Xt equals there. I think that's better. Okay, now to test this thing, let's change our little MPEG our packet reading program to, instead of print out the packet ID, let's see if it can get the PCR, so the clock ref. For now, I'm not going to return an error here just because I can't think of a reason to, although I might just add that to the nodes, wherever they are. I don't know if there's anything else that's kind of invalid in here though. Clock reference is all good. Splicer content, yeah, again, that has to be that. Private, extension. Yeah, okay, so there could be some logical stuff in extension, but yeah, I don't think so. So let's just leave it like that. So there's no error, which is just awesome, right? Yeah, and then we're going to do that. And then when we're finally when we're decoding it, we can actually, yeah, we can do this. Equals parse adaptation field of that from that slice, because we know everything else is we've used already. Yep, okay. And the adaptation in our packet now is actually a pointer to an adaptation. We use a pointer because we want to distinguish between, well, we want to be able to quickly tell, like, hey, is it nil or not? Like, is it set? Because when we're encoding our packets, then we'll want to, rather than having to keep a flag or like check, compare the zero struct or something, we can just do if it's nil, then whatever. Yeah. Okay, cool. So let's do that. Let's run our little reader. Now we've got a packet. So in our program, we have parsed a packet. Let's now see if we can get if there's an adaptation field set in it. So for each packet, if packet.adaptation is not equal nil, let's print something. We'll check if, let's see if there's a PCR. Okay. Yeah, that looks good. Rename adaptation dot PCR dot, and then let's do the ticks. That's that method that we set on it. Okay. Is this going to work? I got no idea. I think it should, but... oh, baby. Out of range, 0 with length 0. Whoa, holy shit. Ah, we're setting that. Okay, fuck, I knew that would happen. Remember I was like, oh yeah, like, do we need it? Okay, yeah. So, well, I think, yeah, we will need an error. Anyway, let's just see this. So apparently we have an adaptation field that is just, oh, the length is 0, right? Yeah, so if length, and just return. Nil? Why would it be so it's saying there's an adaptation field, but it's got length of 0, if we're doing this correctly. No, we're not. Out of what? So the length is is hold up. Adaptation field length, and then we have the flags. I think we're off by 1 up here somewhere. So if the length is 1, then immediately following this byte, it can't be 1 then. Because immediately following this byte, so it says 1 and then there's nothing left. At least we haven't given it enough. Further, sort of up to here. So we do this, parse adaptation field from that buffer. Are we 0? Sync. Okay, fine then. On to the next byte. Okay, 1. Check the flags, check the flags. 1, 2. And all of buff 2, yep. Okay, and then we're on to reading the scrambling, 2 bits. And so we're, and then we deal with these bits down here. Now just get the last 4 bits. Yep, and that's from that. And then we check, okay, well, OX03. So if we're getting adaptation field only 1, 0, oh, have I fucked that up? I have, yeah. That should be 2. Right? Is that right? Yeah, because 01, yeah, 0, 0, 1, 1, 0, 1, 1. Yeah. Okay. Or not. No, sorry, no, I still got it wrong. Field length is 1. So there's 1 byte left, but there isn't. We're mixing this up. It's 02. 1, 2, 3, 4. Payload only. Yeah. Adaptation field only. Adaptation field followed by payload. And then, yeah. Okay, so anything else would, can't do it. Or right, actually, more specifically, let's do this. I'll come up with an error message later for that. That's an error that we want to check for. adaptation field length is 1. How? Let's just go maybe. Well, actually we can do that now, right? And then just do that, and then we'll do yeah, okay, so this really shouldn't be just that. So we're just doing this just so we can just always only get the adaptation field. Fuck. Yeah, 0. Okay, yeah, that's good. All right, so I'll do that. Like this one. Okay, yeah, so I was doing, so the length is going to be, so say we got a length of 3, right? That means go from 1 and then we do the length of 3. Yeah, no. We need +1. Always get that wrong. Okay, nice. Okay, that's something. Okay. Got another one here. So adaptation field length is 0. So what did we hit? We hit that. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. Yeah. This is actually, this looks right to me, because I remember seeing somewhere that they, that it's recommended to send the clock after every, this looks kind of periodic to me. So that's good. So that means that we've just hitting something here. 4 onwards. Again, we're getting the length. So the length, yeah, length is 0. Just return 0, right? I mean, that's just totally not cool. I don't know what that could mean, but okay. How could it be that the adaptation field it's there, but it's length of 0. So there's just 1 byte there that says length. Length of 0. quite get that. Anyway, we return there. And then, okay. Now, yeah, it's all going up, so that's good. Not some random number. Temple OS. Oh no, wait, man. I'm not hardcore enough for Temple OS. I'm not in that league. That's a different league altogether, mate. Let's not do the ticks. Let's just print the base and then see what it looks like, because those numbers shouldn't be as big. What? Oh, so it's actually, oh, okay. So this is just it. Okay. So ticks. We'll do that. And then let's just because I just want to see a 90 kilohertz clock there, because I just feel like that would be a bit, I don't know, these numbers are so big, I can't quite understand it. So where we do that, let's just print, let's print this number, but just print it there. Oh. Oh, no, that's right, yeah. And then just do that. Yeah. If I divide this value by 90,000, I'll actually get seconds. It's because it's 90,000 kilohertz clock, so. Right, maybe. No, maybe not. Maybe not. No. 90,000 V. What we could do is let's do that. Let's print out, no, actually, divided by, oh, no, divided by 90,000. Sorry. Yeah, let's print out that, and then let's have a look at what Wireshark has to say about it. Okay, so hopefully now if I, I'll do that later. Okay, let's see the adaptation field. Control. Where do I want the adaptation field? Here we go. PCR flag is 0. Shit. But I can get this. So that MPEG-TS dot fuck, where is it? AF.PCR underscore flag dot AF dot ACR underscore. Oh, just that. Yeah, that's cool. Okay, nice. clock reference is that in hex. Okay. Can I get that? Copy the value. Or the copy bytes as... Okay. Well, it's just past 5 now, so I am due to go. So I'm going to save that there. Close these. Yeah. I'm going to leave that there for now, I think, or can I save this? Yeah, because I really cannot be late for this thing. Right, close this. Return that. That. Yeah. Okay. Yeah. So I was like, oh, it's just yeah. It is. Yeah. Yeah. Sorry, I can't give an answer now, but basically everything is text. Like really everything is text. And so it integrates well with the operating system around it because standard command line programs read and write text very well. So you can kind of just run commands and run programs from within Acme without needing to really do anything. So that's cool. Yeah, I'm going to run. I'm going to do this. So yeah, thanks again, everybody. Sorry I ended very quickly. I should have given like a time remaining or something. I don't know. But yeah, we started out our MPEG transport stream thing. So awesome, right? That's good. So yeah, just want to say thanks. And yeah, if you got anything to say or want to share anything, yeah, feel free to email that. Yeah, looks good. Okay, cool. See everybody. Good night, good morning, good afternoon, wherever you are. Okay, cheers. See ya.